Good morning, good afternoon, good evening, depending on where you're listening from. Welcome to this webinar presentation. I'm Julian Bright, lead author and a senior analyst with Informa Telecoms and Media, and we're going to be looking through the findings of the recently published research on LTE spectrum strategies and some of our forecasts out to 2016. With near universal commitment to LTE as the next generation mobile broadband technology, our expectation is that over 360 LTE network launches will take place over the period to 2014 and beyond. However, a major underlying concern associated with the rollout of LTE is the availability of spectrum to support the technology and the resulting uncertainty over the pattern of band adoption. In order to address this, 3GPP has already identified over 30 bands, and more bands are under consideration. Leading operators such as Deutsche Telekom have all spoken out on the issue of spectrum for LTE and have acknowledged the risk of fragmentation as being a significant challenge. So what's at stake? Well, this lack of consensus is creating a cycle of uncertainty, with regulators unclear about when and where to free up new spectrum, manufacturers uncertain as to which bands they need to support, and operators looking to both these two parties to be able to move ahead with deployments. The lack of consensus as to demand by frequency band is slowing operators' decision-making processes and threatening to reduce the flow of investment. Some operators choosing not to wait or who are eager to push ahead with LTE rollouts are having to make choices with regard to spectrum, but the spectrum fragmentation is a very real one. So Informa has surveyed 150 mobile operators and 50 regulators in all of the world's main regional markets. Our findings reflect some of the early deployments, showing that, for example, the 2600 MHz band will be the most popular in terms of initial network launches, with bands around 700 and 800 MHz being the next most widely adopted in the initial phases. However, all regions will see deployments in multiple bands, with up to 11 different bands being adopted in any single region. Band pairings will be a common feature, often providing a combination of capacity and coverage. There's also growing support for existing bands such as the 1800 MHz band and for the use of TDD bands alongside FDD. Based on Informa's discussions with operators and regulators, it's been possible to map LTE band adoption by region. These band maps help to illustrate both the number of bands expected to be adopted in any region and the interregional differences in band adoption patterns. Thus, for example, in the case of the European markets, the 2600, 1800 and 800 MHz bands predominate throughout. Moving on to North and Latin America, the 700 MHz band is the dominant lower band, along with 1900 MHz and 2100 MHz in the mid-ranges and 2600 MHz in the upper range. In the larger markets of Asia Pacific, band adoption spans both the European and North American bands, but with strong emphasis on clearly TDD bands in China, historically linked to the adoption of TD-SCDMA technology. There's also a large spread of bands being adopted in the Japanese market. Southeast Asia broadly follows the European band pattern, but with 700 MHz favoured at the lower end. In the Middle East, the European band plan applies, so there's a degree of commonality there. Operators in Kenya and South Africa, however, in the African market are also favouring the 700 MHz band. I mentioned that in any one region a significant number of bands have been identified for adoption. This example is Asia Pacific, with no fewer than 11 bands so far identified. This is the largest spread we've so far come across in any single region. But within that Asia Pacific market, focusing now on Japan, Japan has 7 different bands earmarked by operators for LTE. The most popular bands throughout the forecast period in terms of their percentage of the total addressable market are the 900 MHz and 1500 MHz bands, the latter being adopted by both NTT Docomo for its Crossi service and by KDDI. The 700 MHz band makes a late appearance but represents a comparable addressable market by 2016 to these other 2 bands. Band pairings, often in order to build a combination of capacity and coverage, are a feature of regional band adoption. Hence the 800 MHz and 2600 MHz pairing in Western Europe, which is expected to be expanded by the inclusion of the 1800 band as operators refarm their GSM 1800 services to create space for LTE. Informa has identified 8 core bands, which represent the largest bands in terms of the addressable market share over the forecast period to 2016. These comprise the 700, 800 and 900 MHz bands, 1800 in the mid-range and 2100 UMTS band, 2600 FDD and TDD, and the 2300 MHz TDD band. Within the context of core bands, it should be borne in mind that even within these groupings, the channel distribution may have implications for product planning on both the infrastructure and device side, often creating the need for distinct products or product variants. The example in this case is the 700 MHz North American band, which is divided into upper and lower bands whose configuration is specific to individual operators. Similarly, the 700 band, as identified in other markets, may differ as may aspects such as the bandwidth specified within an individual band. So there's a degree of granularity here which exists below the core bands identified currently in our research. Licensing of some core bands, such as the 2600 MHz band, has been slow, although a number of regulators, for example in some of the major markets of Western Europe, are now pushing ahead. Timescales for the licensing of the digital dividend bands seem to be less clearly defined in many cases, often due to the uncertainty over timescales for these bands to be freed up for mobile broadband. Informa's research has identified growing support for the TDD bands, driven aggressively by China Mobile, and increasingly because the TDD spectrum is seen as both complementary to FDD as well as being less expensive. Because of its asymmetric nature, TD-LTE is also widely regarded as being more efficient in meeting the demands of certain traffic types such as internet and video. As well as widespread trials and vendor support, TD-LTE is also expected to launch in 17 countries by 2014. An industry group led by China Mobile is also supporting the creation of a converged TDD, FDD, LTE ecosystem, and vendor support for the TDD variant of LTE is already significant and growing in all areas through infrastructure, chipsets and devices. TDD or TD-LTE also has the attraction that it provides a migration path for WiMAX operators from their existing WiMAX technology to TD-LTE. Coming on to the forecast section of the report, our research includes subscription forecasts and addressable market by band out to 2016, as well as LTE penetration by population and total subscription. Also forecast launch dates for LTE networks by band, country and operator. LTE footprint maps show the global distribution for each of the core bands with timelines. So just to look at some sample data sheets from the report, forecast LTE launch dates by band gives a global picture out to 2016 of LTE launches within each of the major core bands. Operator level launch dates includes confirmed launch dates and informers forecast launch dates by operator for LTE within the major bands. Subscription forecasts Informer envisages a steadily growing subscription base for LTE over the period to 2016 with in excess of 600 million subscriptions by the end of the forecast period. This slide shows how the global addressable market for the core spectrum bands breaks down over the forecast period. As new bands such as the 800, 1900 TDD and 2300 TDD bands come on stream, and as refarming takes effect in the 1800 MHz band, so the distribution becomes more even across all of the core bands. Looking at this distribution on a per band basis, the global distribution of the addressable market for the 2600 MHz band, for example, shows Western Europe representing over 40% of total by 2016, with Latin America as the second largest addressable market, followed by Eastern Europe and Asia Pacific. Similarly, for the 700 MHz band, North America remains the major market over the forecast period, but with Asia Pacific showing significant growth over the period 2014 to 2016 as the band comes on stream in the region. Overall, the global addressable market for this band is around 160 million by 2016. Moving on to the issue of spectrum refarming, the most promising candidate band for refarming, certainly in European and Asia Pacific markets, to emerge from our survey, is the 1800 MHz band. Benefits cited by operators include improved coverage compared to the 2600 band, reuse of network resources, widespread availability of spectrum, and the anticipated availability of devices within a reasonable time frame. On the device side, Informer's research suggests that it may take 12 to 18 months for dual-mode LTE GSM chipsets to become widely available. So some operator expectations for an early availability of devices may be a little optimistic. But clearly this band is widely or gaining wide support as an LTE deployment band. So we'll now have a look just at some of the challenges of achieving that. These relate to three areas: regulatory, strategic and technical. The regulatory barriers in Europe, for example, are only just being removed in many markets with implementation of the recent EU directive on the use of the 900 and 1800 MHz bands for mobile broadband services other than in addition to GSM. Careful planning and protection of existing revenue generating services is clearly a key concern for operators. The technical challenges of moving to a refarming strategy for the 1800 band can be facilitated through the implementation of a single RAN type approach as an initial step towards refarming. Coexistence of technologies within the band is a key concern. Establishment of adequate guard bands will clearly be an issue where existing GSM and future LTE services coexist. Moving on to LTE devices. Clearly, multi-band devices will be key for achieving the necessary economies of scale. Continuing support for legacy services is critical on the device side, but devices need to be able to take advantage of LTE's high bandwidth where coverage is available. Device vendors will therefore have to rationalize the number of LTE bands they want to support in order to meet cost, power consumption and device size considerations. Design challenges are associated with aspects such as antenna integration, LTE modem design, support for voice over LTE, and these all mean that, as I've said, vendors will need to rationalize the number of bands that they can support. Cost, power consumption and size considerations are clearly key. A likely scenario from our perspective is that support for up to 5 existing bands, including GSM and CDA, would need to be supplemented by probably 5 new bands for LTE, as well as Wi-Fi, Bluetooth and GPS. Clearly the issues here are relating to within market and within region roaming. Global roaming will be a consideration further into the future, but clearly initially operators' concerns will be within their immediate national and regional markets. The device status as of Q1 this year. Connectivity today is currently provided mainly via portable routers, dongles and connected netbooks. Only 2 operator services, both in the US, are currently providing smartphones. Of the 71 mobile devices so far announced, this includes netbooks, notebooks, tablets, smartphones and USB dongles. Only 22 are currently in service, and the majority of these being single band LTE. Not surprisingly, the most widely supported bands are the 700 MHz and 2600 MHz bands, in line with early launches in the European and US markets. Interestingly, of the 130 LTE compliant consumer electronic devices we've identified, 45% are targeting fixed wireless applications. LTE device status clearly shows widespread vendor support for LTE, with 1 or 2 notable exceptions. So, coming to the conclusions, clearly widespread uncertainty over spectrum availability is frustrating operators' LTE deployment plans, creating doubts over the future availability and timelines. Examples, well, certainly we've heard of one, Telstra in Australia, an operator is pushing ahead with LTE deployment plans despite clear dissatisfaction with its currently available spectrum options. Operators are having to approach launches in a sort of pragmatic fashion if they're keen to push ahead and use currently available spectrum resources in the best way possible, pending future licensing rounds and freeing up of other bands. Measures designed to provide more flexibility, such as defining a large choice of bands for LTE, have had the dual effect of creating that flexibility, but also feeding to some degree the uncertainty. So a more detailed picture of spectrum availability is clearly a critical concern and hopefully a beneficial one as far as the industry is concerned. Our research has identified the addressable market by band, which we consider an effective means of building a growth profile for LTE spectrum. In our research, this has revealed aspects such as the distinct regional nature of band availability and preferences for band pairing among operators, as well as the evolving map for global LTE band adoption over the next 5 years. This in turn can help both infrastructure and device vendors to focus their efforts and help build the necessary economies of scale. Over time, the relative market shares, as we've seen, of the core bands will change, and this will be an evolving picture out to and beyond the forecast period to 2016. Finally, a recap on some of the key findings of our research. All regions will see LTE deployed clearly in multiple bands. Currently, high-end bands at 2300 and 2600 are expected to address the largest market share by subscriptions over the forecast period. Growing support for TD-LTE is evident, although China will remain the major market out to 2016 for bands such as 2300 MHz TDD. The 1800 band is clearly attracting widespread interest, and during the course of the forecast period, as the various challenges attached to refarming are addressed, adoption of this band is expected to grow. The band plan continues to evolve. 3GPP has already, as I said, defined over 30 bands. More bands are under consideration. Sub-bands may be refined, some bands may be consolidated, some bands may be abandoned in favour of other combinations, and those clearly that provide the greater opportunities in terms of bandwidth for LTE will be attractive. So there can be one can expect to see further activity in terms of definition of bands for LTE. Devices will continue to be a major challenge. Our research shows that there are significant challenges in terms of integration, maintaining cost and size constraints, or working within cost and size constraints while integrating support for multi-band LTE. So we anticipate a degree of rationalization on the part of device vendors in terms of the bands that they're able to support. Thank you, and that concludes the presentation.